Okay, we'll continue our study. So we want to look for proportionality. So this is what we are looking for. One easy way is solve this for all of them. Y divided by x. Okay, and if everything's consistent, then you're good to go. That is proportionality. Okay, so like for example, in the first case, you're getting 3 over 6, and then you're getting 6 over 8. So, and then 9 over 12, right? So are these the same ratio when I'm dividing y divided by x? Am I getting the same answer? If I get the same answer, then I should check that box. Now let's look at the third one, the second option, this one. So we get 4 divided by 3, and then 8 divided by 6, and then 20 divided by 15. So if I multiply this ratio by 2, do I get this? Yes, I do. If I multiply by 5, do I get this? So this one is checked as correct. And then treat this one. Times 2 is this, times 3 is this, right? Times 2 is over here, times 3 is over here. So this works, both of them. Okay, let's try another one, just to give you an idea. Remember, you're dividing y by x to see if the proportionality is the same. So y divided by x, 3 divided by 5, 6 divided by 10, 9 divided by 15. See if these ratios are the same, right? You can plug it into your calculator and just figure it out, right? So this one is checked. So 3 times 2 works, 3 times 3 works, 5 times 2 works, 5 times 3 works, right? So it should be the same number that you're multiplying. Okay, now the second one, it's 6 divided by 1, then 9 divided by 2, right? So 6 divided by 1 is 6, 9 divided by 2 is 4.5. Doesn't work. So use that idea to your advantage. This is not the same as this. So therefore it doesn't work. So let's just submit the first one. And then let's go to the next. IXL R20. Identify proportional relationships by graphing. So here we've got to now plot this, right? So Pete is participating in a fund run to raise money for the West Side Children's Hospital. The run is held at Pete's high school track. The more laps Pete runs around the track, the more money he raises for the hospital. Maybe at some point your school did something like this. If Pete runs 1 lap, he raises $5. If he runs 2 laps, he raises $10. In this relationship, X represents the number of laps Pete runs, and Y represents the amount of money he raises. Graph 2 points for this relationship and the line passing through them. So this is fairly easy. If he runs 1 lap, the laps are over here. If he runs 1 lap, he gets $5, I think. He raises $5. So 1 and 5. So that will be your first point, right? And then when he runs 2 laps, he raises $10. So 2 and 10. So that's your line. According to the graph, do you have a proportional relationship? Or every lap giving you an extra $5? Yes. So it is proportional. And let's hit submit. And that's about it. So read the question carefully, and the points are already given to you in the question. You just have to plot them. To make some extra money on the weekends, Ayana drives for the City Express ride sharing service. During regular hours, passengers are charged a flat fee plus an additional fee per mile of the ride. A passenger who rides 5 miles in Ayana's car is charged $9. So here we'll just plot. So I think it's at 5 it's 9. Something happened to my screen, but at 5 it's 9, and at 6 it's 10. So you'll get a line like this, right? So it is proportional. Let's try another one. Here we've got interpret graphs of proportional relationships. Susan loves to wear socks with crazy patterns. She finds a great deal for these kind of socks at her favorite place. Rock those socks. The graph shows the proportional relationship between the number of pairs of socks that Susan buys, X, and the total cost, Y, in dollars. So what does 1 comma 2 represent? So remember, just look at the axes. So 1 is representing the pair of socks and 2 is representing the dollar amount. Maybe let's use a different number for a color. So that's 2. So so $2, right? So look for $2 and one pair of socks. Boom. So just read what's happening. Look at this, analyze, because these analyses will help you a lot in the future. Okay, let's try another one. So every few years, Reagan's entire family gets together for a family reunion. This year, Reagan's parents are hosting, and they have a cook. I have to cook a lot of food to feed the crowd. Reagan has volunteered to do the most tedious job, shelling peas. Have you ever done shelling peas? It is quite tedious, but it's also fun. Okay, you should try it sometime. Do some work. Okay, let's do some math work. All right, let's get back to work. The graph shows the proportional relationship between the amount of time in minutes Reagan spends shelling peas and the weight in pounds of the peas she has shelled. So 8-4, right? What does 8-4 represent? Now again, look at the axis. 8 is on this, so the time is 8 and this is your pound. So 4 pounds and 8 minutes. Look for that option. So after 8 minutes, Reagan has shelled 4 pounds of peas. Okay, and then the last one. Okay, let's go to the last one. If you have any questions, please just ask. As always, scale drawings, word problems. So scale drawings are something like Google Maps, right? Google Maps use a scale drawing, or any map that you see is a scale drawing. Uh, so Olivia made a scale drawing of a neighborhood park. The scale of the drawing was 1 inch to 2 yards. In the drawing, a soccer field in the park is 59 inches long. What is the length of the actual field? So we are back to what we started off with. So 1 inch and 2 yards, right? 59 inches box. So here then we see that 1 times 59 is 59 and 2 times 59 is 118. We can plug that in and we'll get our answer. All right, good luck with these exercises. I hope everyone can complete all of this. This is a good skill to learn. It will help you in consumer math, it will help you in regular math, it will help you even outside math. You'll end up dividing things, exploring things, dividing money, sharing, whatnot, and that would help you out. All right, have a nice one. Bye bye.